Hey guys, welcome back. Lesson 25. Feels good, doesn't it? It's going to feel good to get finished with 25, isn't it, right? Okay, we're going to mess around with division and mixed numbers and all kinds of that stuff. Remainders versus mixed numbers. Well, anytime you see something like this, if you say I don't know, 3 divided into 25. Let's say 3 into 25 we know is 8. And 8, we'll just pretend like we're doing the division problem. Oh, that's going to be 1 left. You go, oh, that's 8 remainder of 1. Another way of writing the same exact thing is to actually take this number and make it a numerator and make this number a denominator. So we'll say the same thing, 3 into 25, we can go, of course, 8, 24, and 1 left over. You go, okay, 8, and then put this number on top. That's 8 and 1, and then put this number on the bottom, third. And there you go. 8 and 1/3 is the same thing as 25. Look at this. 25 divided by 3. So when you see, don't forget, let's say 68 divided by 7 or something like that. That's a division problem. Every fraction is a division problem. This divided by that. The top number is what's being that's what you're dividing that the denominator into. So let's just do it for example. So 7 into 68. Well, 7 into 68 is 9. 9 times 7 is 63. There's 5 left over. You could say remainder 5. Or you could just say 9, and then you tell me, based on this, what would the fraction be right here? The 5 goes on top, right? And the 7 goes on the bottom. There you go. So this 9 and 5/7 is the same thing as 68/7. So you can either write a number that looks like this with the fraction 68 over 7 divided by 7, or you can write it as a mixed number 9 and 5/7. Same thing. Okay, that's all. All right, well, let's do a couple of these. 19 cookies were divided evenly among 4 children. How many cookies did each child receive? Well, I don't know. We'll see. So we got 4 divided into 19. Well, 4 into 19, of course, is 4, and that's 16. There's 3 left over, okay? We don't put remainder 4. We put 4 and 3. That's that number on the top, then this number here. So each kid got 4 3/4 cookies. All right. And they all got sugar glucose-induced hypoglycemia. Okay, after that. All right. An entire pie is 100% of a pie. All right. What percent of the pie is 1/3 of the pie? Well, 1/3 just means we're dividing by 3, right? Okay. So let's just divide 100 by 3. 3 into 100. 3 into 10 is 3. I'm going to do short division. 3 to 10 is 3. There's 1 left over, right? When you multiply that. So there's my 10 right there. 3 into 10 is obviously 3 again. And it's a 9. And of course, we know 1 is left over again, right? So we can put the 1 on the top in the fraction, and the denominator is a 3. So what percent? It's 33 1/3%. There we go. That's it. All right. Okay. You do this, pause it, write this as a mixed number. In other words, just do the division and don't write remainder, make it into a fraction. So pause it right now and do this. Okay, well, let's do them. 8 goes into 37. I'm just going to do this in my head here. That goes 4 times, right? What's left over? 5 left over. That goes on top. This goes on bottom. There's my answer, 4 5/8. That's all there is to it. Okay, all right. Let's do multiples. You should know the word multiple. It's almost like the opposite of factors, but not exactly. But let's say multiples of 10 are 10, 20, 30, 40, 50, 60. Multiples of 6 are 6, 12, 18, 24, all that kind of jazz. So you just times 1, times 2, times 3, and you just keep going. The difference from factors, you tell me the multiples of 10 are, we just said, 10, 20, 30, 40, 50, blah, blah, blah. The factors of 10 are 1 times 10, right? And 2 times 5. So somebody asks you, oh, the factors of 10, you're going to go, okay, 1 and 10, and then 2 and 5. You're done. And somebody says the multiples of 10, they'll say, what's the 12th multiple of 10? You'll just go, oh, 10 times 12, oh, 120. That's it. The factors of 20 would be, 20 times 1, 4 times 5, 10 times 2, and so on. The multiples of 20 would be 20, 40, 60, 80, and so on. That's it. So let's mess with a few of these. What are the first 5 multiples of 6? Well, piece of cake, right? 6 times 1 is 6, 12, 18, 24, 30. There you go. All right. What's the 7th multiple of 6? Well, that's a piece of cake. You don't have to sit there and write, let's see, 6, 12. You don't have to do that. What's 7 times 6? That's all you need to know. 7 times 6 is 76. So that's the, okay, no, 42. All right. Okay, that's it. All right, try the practice set. I've got this set up for you to do all the problems at one time. So go ahead and do all the way A through I. Pause it and check all your answers. So go ahead and pause it. Okay, let's look at these. 28-inch long ribbon was cut in eight pieces. 8 goes into 28. 3, you might have put 3 and, excuse me, 3 and 4/8, but you reduce that fraction to 3.5. B, what percent is 1/7? Well, you would just say 14 and 2/7. In other words, 100 divided by 7 would be 14 and 2/7. C is 46 and 7/10. D through I, there you go. The only thing I think you might have trouble with is F. That was kind of an interesting one. 24. And mixed numbers, G, H, and I. All you're doing is literally, remember, don't forget that fractions are division problems. So when you look at G and H and I, it's not just, you can either say, oh, it's 35/6, which is fine. Or you can also say 35 divided by 6. That's going to be 5, and then 5 left, 5 and 5, 6 left up. That's all you're going to do. H, 49/10. That's fine. If you want to say it that way, you can also say 49 divided by 10. Whatever. Okay. All right. Have a great day with those, and we'll see you next time. Do the best you can, and see you tomorrow.